Good morning, everybody. Welcome back to our YouTube channel. Okay, so today we're going to be presenting the POE, also known as the post-occupancy evaluation, and our evaluation is going to be based on acoustics and occupancy in town hall. This evaluation focuses on analyzing sound levels and occupancy patterns at different times of the day, as the name implies, and the goal of this POE is to assess how well the space meets acoustic standards and ensures user comfort with findings based on detailed result analysis. I know big words, but we'll get into it. So to really understand a POE, we got to explain you the importance of a POE, and it lies in its ability to assess how well a space performs after it has been occupied, and it also helps us identify how the space meets the intended design objectives, like the design decisions that they took. A POE also provides valuable insights into how the space is actually being used and how it can be improved. Because why would you want to be stagnant when you can be on top? Okay, on that note, I'm gonna hand it to Kiana.
The reason as to why research is being conducted is because A. Feedback for design improvement. It gathers real world insights from occupants, helping to identify design strengths and areas needing refinement. It enhances operational efficiency, evaluates energy performance, indoor environmental quality, and facility functionality to improve operational systems. Occupant satisfaction assesses how well the building meets the needs and expectations of its users, informing future design decisions. Informed decision making provides valuable data that can guide maintenance strategies and future projects, leading to better outcomes. Risk management identifies unforeseen health, safety, or performance issues early, allowing for proactive interventions. Sustainability assessment measures how effectively sustainable design strategies are working, suggesting areas for enhanced environmental performance. Benchmarking and best practices offers comparative insights with similar projects, contributing to industry knowledge and improved standards. Urban design and planning firms. Companies specializing in public space design, such as Gale Architects or ARUP, conduct POEs to improve urban environments by studying user behavior, accessibility, and spatial efficiency. Smart cities and public space research. Government backed initiatives in cities like Dubai or Singapore use POE methods to improve plazas, parks, and study spaces through observation, surveys, and data analysis. Case studies in university, town halls, and plazas. Universities worldwide, such as MIT, UCLA, or Delft University, analyze how shared space functions for socializing, studying, and events, providing insights applicable to your project. Case studies and journals linking acoustics and occupancy comfort. Office environments. Acoustical analysis in office environments using POE surveys. This study by the Center for the Built Environment at UC Berkeley examines how acoustic conditions affect productivity and workplace satisfaction through occupant surveys. Acoustic comfort in open plan offices. The role of employee characteristics. This research explores how individual differences, such as noise sensitivity, influence perceptions of acoustic comfort in open plan offices. Educational buildings. Special use. Acoustical comfort in educational buildings. This collection of studies encourages exploration into acoustic quality in educational settings, addressing topics like individual differences in acoustic perceptions and optimal acoustic design. Urban public spaces. Development of the Acoustic Comfort Assessment Scale ACAS 12. This study presents a scale for assessing human perception of acoustic environments in urban public spaces, highlighting its psychometric properties and validation.
Okay, environmental importance. All of us SDT folks know a lot about this. Okay, so why does this research matter for sustainable and comfortable environments? Basically, it confirms if sustainable strategies meet their targets to optimize energy, ensures a healthy indoor environment, informs better design practices, enhances long term operational performance, provides evidence for green credentials. For example, if we have reduced noise, then quiet environments help individuals concentrate better. Now let's come to the statistics. So, if we talk about the established standards, noise levels according to ISO 3382-3, speech intelligibility improves when ambient noise levels remain below 45 decibels, preventing background noise from interfering with clear communication. Basically, I'm the clear communication, and it's 45 decibels in this room right now because the noise is very faint because y'all aren't talking.
Similarly, the ANS and the ASA S12.60 standard recommends that background noise should not exceed 45 decibels in spaces, intimate conversations like cafes, town halls, etc., to maintain an optimal signal to noise ratio. BS 833 also emphasized controlling ambient noise in public spaces with a recommended maximum of 45 decibels to create a comfortable acoustic environment. Regarding occupancy density, it's recommended to have a standard of 1.2 to 1.5 persons per square meter to prevent overcrowding and allow adequate space for movement and conversation. This helps manage both noise levels and ensure occupants aren't overwhelmed by excessive noise or uncomfortable acoustics. Thank you.
Furthermore, environmental impact and relevance. Why is this research so important, you might ask? Because we want to assess the acoustic performance after the construction of the town hall, which is now. And the methods that we will be using to do this is collecting qualitative data, for example, the surveys and interviews on noise perception, comfort, and challenges, and then collecting quantitative data, sound pressure levels, reverberation time, and speech intelligibility. This will then lead us to our outcome because we're not doing this for nothing, and we will eventually identify gaps in design and inform future acoustic improvements. This also has an impact on user comfort, for example, privacy and focus, like how noises in the background can hinder your concentration, speech ineligibility. If there's a lot of noise going around and you're not going to be able to talk properly, noise control, for example, reducing distractions and creating a comfortable environment, and so on. Our POE insights may improve the material selection. For example, some materials have better noise absorption than others, and maybe even if developing more construction techniques, for example, making a green wall, because plants are really also good at absorbing noise. This will all lead to more comfortable, productive, and oriented spaces. And finally, our aims and objectives are to evaluate the impact of acoustic quality on occupant comfort and behavior in Harry Watt University Dubai campus town hall. Period.
The main entrance is located on the side leading to the inside sitting area, which spans about 218 square meters and offers ample seating. Adjacent to this are study boards, each measuring 1.8 meters by 1.8 meters, designed for focused work or small group studies. On the right side of the plan, there is a cafe. Additionally, an outside sitting area is available for those who prefer an open air environment. The entire space has a ceiling height of 4.79 meters, contributing to an open and airy atmosphere, making it an ideal setting for both social and productive activities. Town hall is chosen for this POE study due to its high occupancy, diverse usage, and significant acoustic elements. As a space designed for public meetings, events, studies, and discussions, it experiences fluctuating noise levels and varying occupancy conditions throughout the day, making it an ideal environment to study the relationship between acoustics and user comfort. One of the key factors influencing this choice was the architectural and material composition of the space. As Town Hall features high ceiling, open layout, and reflective surfaces such as glass facades and wooden study boards. Additionally, multiple noise sources, including crowd interactions, HVAC system, external environmental sounds, pose a challenge to maintaining an acoustical comfortable atmosphere. This post-occupancy evaluation on acoustics and occupancy assesses noise level, user perception, and space usage through a combination of sound level measurements. user surveys, and occupancy observation. Data collection was conducted across 3 time intervals: morning 9 am to 12 pm, afternoon 12 pm to 4 pm, and evening 5 pm to 9 pm to capture variation in acoustic conditions. Number 1. The sound level measurements. A sound level meter was used to record noise levels at single location, approximately in mid and 1.2 meter high, ensuring a broad representation of noise variation. The equipment was calibrated at 135 decibels for an extended range, but was unable to record lower frequencies, leading to some uncertainty in data analysis. Measurements were conducted over 2 days to assess noise trends under typical conditions. Occupancy observation and user surveys. Occupants' behavior was recorded over a span of a week, documenting the number of people, activity levels, and movement patterns to correlate with noise fluctuations. User survey collected feedback on noise disturbance sources, overall satisfaction with the acoustic environment. By integrating these data collection methods, the study provides a comprehensive evaluation of acoustic comfort, helping to inform design improvements and noise management strategies for better spatial performance.
The data gathered is primarily quantitative data with some qualitative elements. Sound level measurements give numerical output recorded in decibels at different times and occupancy conditions, allowing comparison with international standards. Occupancy observations include numerical data on the number of people and their activity, with qualitative aspects focusing on their position and the type of activities they are engaged in, which may influence noise levels. Lastly, user questionnaire responses are quantitative because these were designed as multiple choices and scales to assess occupant perceptions of acoustic comfort.
To analyze the usage patterns of the town hall and the impact of noise levels on users, user questionnaire was designed on data points as frequency of visits, purpose of use, time of visit, duration of stay, noise perception, and improvement suggestions. How often do people visit the town hall? Frequent users, several respondents visit daily. Occasional users, some visit a few times a week or rarely. Once a week users are minimal. Primary reason for visiting: eating is the most common reason. Other reasons include studying, socializing, group discussions, and relaxing. Time of visit and stay, duration of stay. Peak hours: most visits occur in the afternoon around 12 pm to 4 pm, followed by morning, which is around 9 am to 12 pm. Stay durations: most visitors stay for less than 30 minutes. A few stay for 30 minutes or 1 hour to 1 to 2 hours, mainly for studying or socializing. Noise perception in town hall. Noise level readings: majority of users rated the noise level as 4 or 5, which are the high levels of noise. A few respondents rated 2 or 3, which are the moderate noise levels. Impact on concentration: many respondents stated that noise frequently or always affected their ability to concentrate. A few reported slight or no impact. Main sources of noise: conversations were identified as the biggest source of noise. Other sources include background music, chairs moving or furniture noises, and kitchen or cafe activities. Methods of managing noise: headphones or earplugs are the most common solutions users preferred. Others prefer to leave the space or move to a quieter area. A few respondents attempt to ignore the noise. Suggested improvements: more designated quiet areas was one of the most common requests. Better soundproofing to reduce noise distractions. Lower background music volume to improve focus. Key takeaways or analysis: the town hall is primarily used for eating, studying, and socializing. Afternoon is the busiest period, with short stays being common. Noise is a significant issue, mainly due to conversations and background sounds. Most users struggle with concentration and rely on personal noise management methods. Over a week of observation, the team noted distinct usage patterns in the town hall. Mornings were primarily occupied by individuals socializing and studying, while the afternoon saw peak occupancy with high noise levels as users engaged in eating and socializing. In contrast, late hours and weekends had a more relaxed atmosphere, with most visitors utilizing study pods for individual or group study. Sound measurements confirmed these trends, with afternoon being the noisiest period, whereas the late hours were significantly quieter.
Occupancy and activity levels vary significantly across different time intervals, and these all were averaged for over the span of a week. The morning 9 am to 12 pm, the space accommodated around 18 to 20 occupants, primarily engaged in studying and quiet conversations. During the afternoon period, 12 pm to 4 pm, occupancy peaked at 55 to 65 individuals, with a mix of socializing, studying, and eating, leading to increased noise levels. In the late hours and evenings, 5 pm to 9 pm, occupancy dropped to 5 to 10 occupants, with activities mainly consisting of study, eating, and occasional social interactions. These fluctuations in occupancy and behavior patterns directly influence the acoustic environment, impacting noise level and user comfort.
The recorded noise levels significantly exceeded the recommended 45 to 50 dB standard, impacting user comfort throughout the day. Morning and afternoon measurements ranging from 11:45 a.m. to 1 p.m. between 65 dB and 73.3 dB exceeded the standard by 15 to 25 dB due to chatter, road traffic, and group gatherings. By 2:30 p.m., noise dropped to 58.4 to 61.2 dB, still 8 to 16 dB above the recommended range. Evening levels gradually declined, with 5:30 p.m. readings at 55.1 to 56 dB, while 8:15 p.m. finally approached acceptable limits at 45 to 46.7 dB. The user survey confirmed that peak noise hours led to increased discomfort and reduced concentration, especially during events happening around. However, participants found the evening environment significantly more comfortable, aligning with the drop in decibel levels. These findings highlight the need for noise control strategies to enhance acoustic comfort, particularly in high activity periods.
Survey responses collected during the POE confirmed that peak levels negatively impacted users, leading to increased discomfort and reduced concentration, particularly during events and high activity periods. In conclusion, our findings emphasize the need for effective noise control measures to improve acoustic comfort, particularly during peak hours. Recommended interventions include the incorporation of sound-absorbing materials, spatial adjustments to minimize noise transmission, and scheduling strategies to reduce high traffic disruptions.
Y'all don't play with it because the next thing we had to face was the challenges, and there was some challenges in the acoustic data that we got. First of all was the variability. Like we were so vulnerable. Like the town hall experiences so many fluctuations, like from the traffic outside and the kitchen sounds and then the air conditioning and the music and the customer conversations. Like, oh my god, it can get so overwhelming. And then also there were so many unpredictable sound events, like people would just randomly start laughing and the espresso machine would just go boop babbity boop, and it would just make like random spikes all of a sudden and it would just get noisy, so it made it really hard to get some good stable readings.
The limitations we face was that not all high levels of noise correlates with a high number of people, but can be due to a number of different things. External influences such as weather can also affect our data. If data isn't recorded at the same time every day, that could affect trends and be recorded incorrectly. The possible solutions that could help with data collection is that we can use multiple measurement points to record sound levels more accurately, as well as ensure that we keep sound meters at the same settings and location each time a recording is performed. We could also make notes on events that happen within Townhall, such as live events, group. Oh my god.